Hello. Yesterday we talked about solving systems of equations by using graphs. Today we're going to talk about solving systems of equations using what's called elimination. And today's lesson is technically for April 23rd. That is a terrible 23rd. Okay, so in your notebook, if you want to label it, solving systems of equations using elimination. And today we're going to talk about what elimination is. So we're going to start out by reviewing. And how we're going to do that is by identifying the opposite of each of the following terms. So, for example, term number 1 is 8. So the opposite of 8 is negative 8. Term number 2 is negative 10, and the opposite of that is positive 10. Term number 3 is y, so our opposite is negative y. Term 4 is 3x, so the opposite is negative 3x. And finally, term 5 is negative 34a, so the opposite is positive 34a. I would write down that we know when two terms are opposite because they will cancel out or equal 0. So if we look above again, 8 minus 8 is 0. Negative 10 plus 10 is 0. Y minus y is 0. 3x minus 3x is 0. And negative 34a plus 34a is 0. Or they would all just cancel out. So today we're going to look for opposites of terms so that we can eliminate them or cancel them out. When using the system of elimination, you need to eliminate one of the variables, which can be done by adding or subtracting the two equations you have been given. So, for example, solve the following systems of equations by using the method of elimination and check your solution. First thing we're going to do is look at our two equations. If we look at our two equations for number 1, you should be able to tell that there are two things that are opposite here. Negative 2y and positive 2y. Those are the opposite. So if we add these two equations together, we would get 6x equals negative 18 because those would cancel out. Then we could solve for x. Divide by 6, and x equals negative 3. But if you remember when we were talking about graphing, we wanted to find a coordinate pair where the two things would cross. So now we need to take one of our original equations, which I'm just going to take the first one, x minus 2y equals negative 19, and solve for y by substituting negative 3 in for x. So negative 3 minus 2y equals negative 19. Add 3 to both sides. Negative 2y equals negative 16. Divide by negative 2. Y equals negative 8. So our solution would be negative 3, negative 8. Our second example, y plus 3x equals negative 2, and 2y minus 3x equals 14. Again, in our second example, you should right away see two things that will cancel out. And in this case, it's our x's. So again, since they're opposite, we're going to add. Y plus 2y is 3y. 3x plus negative 3x is 0. Negative 2 plus 14 is 12. Divide both sides by 3. Y equals 4. But again, our solution needs to be a coordinate pair, and we don't know our x value right now. So we need to substitute y equals 4 into one of our original equations. And again, I'm just going to choose the top one. So we have y plus 3x equals negative 2. We're going to sub 4 in for y. And then just solve like normal. Subtract 4 from both sides. 3x equals negative 6. Divide both sides by 3. X equals negative 2. So your solution is negative 2, positive 4. Recap. These are the steps listed out for you. Notice I say I would for sure write this down. Solving systems using elimination. Step 1. Write the system so that the like terms are lined up. Step 2, add or subtract the two equations, eliminating one of the variables. Solve for the other variable. Step 3, substitute in the answer you found for the first variable and solve for the remaining variable. Step 4, write your answers from steps 2 and 3 as an ordered pair and check your solution. I'm going to do 2 more examples with you. X plus y equals 15 and x minus y equals 5. So step 1 says to make sure the systems are lined up. So I'm going to rewrite it as x plus y equals 15 on top of x minus y equals 5. Add or subtract the two equations, eliminating one of the variables. So since we have 2 that are possible to eliminate, I'm going to choose the x's so that I can show you subtraction. So these are like terms, they're exactly the same. So instead of adding like we did on the first 2, we can just subtract the two equations. So x minus x cancels out. Y minus negative y becomes 2y because subtracting a negative is the same as adding. Equals 20. Solve. Y equals 10. Step 3, substitute in the answer you found for the first variable and solve for the remaining variable. So again, I always just use the first equation. It doesn't really matter which one you choose. I'm going to substitute 10 in for y. So I have x plus 10 equals 15. Subtract 10 from both sides. X equals 5. Step 4, write your answer as a solution ordered pair. So I'm just going to write it up here since I don't have space. 5, 10. Make sure you remember x is always in front. So there we would have 5, 10 as our solution. All right, we're going to try those 4 steps again. So step 1, write them so that the like terms are lined up. So we have 2x plus y equals 40, and then x plus 2y equals 50. So right now you might notice that neither of our 2 equations have something that will cancel out because there are no opposites here. So what we can do is change the entire first equation by multiplying the entire thing by 2 so that we will end up with 2y, so our 2y's can cancel out. So I'm going to rewrite that over here. 4x plus 2y equals 80. And then our other stays the same, x plus 2y equals 50. And again, since they're both positive, we're going to have to use subtraction here instead of addition. 4x minus x is 3x. Our y's will cancel out, and it'll be 3x equals 30. Divide each side by 3. X equals 10. Step 3, substitute that back into the original equation. 2x plus y equals 40. So I'm going to take my 10, substitute it in. 2 times 10 plus y equals 40. 20 plus y equals 40. Subtract 20. Y equals 20. So my solution, 10, comma